Happy day, YouTube. My name is John, and this is my channel, The Intermancer. It's been a minute since I recorded a video, and the last video I published I sat on for a couple of months before I pushed it out there. So I think in that video I said it had been a couple weeks since I last recorded. It's been a while longer since then, since I've recorded. But I'm back to it now, probably for a little bit, and I am ready to move forward with my genetic AI framework called Gaia F. Today, it is our good fortune to start putting together the experiment controller's coordinator. I'm hesitant to use the word controller because generally a controller these days means something that provides data to a front end or controls provides access to control things from the front end. So I have controllers, and I'll have an experiment controller, which will be the thing that will be used to control it from an API perspective. But we will be working today on the experiment coordinator, which will be the piece that will start and run an experiment. Now, I've done some work already on the experiment code, but I've been thinking about it, and I'm going to update that, make it a little bit more robust, and so that I can add some other functionality like listeners and things, so I can notify various parts of the system back and get real-time updates on my UI once I get to building the UI. Okay, all of that being said, let's go ahead and get into it. I have this experiment class, which just has the seed method, which seeds the organism repository. But what I'm going to do, as I have been doing, is start with the context file. And I've decided that I'm going to turn experiment into an interface that describes the different phases of an experiment. And what I currently have as experiment, I'm going to turn into the experiment implementation. And I'll call it probably basic experiment implementation to start. So let's go ahead and start by doing that. Let's start with the context file. And let's see, we've got seeder, experiment life cycle, seed, classes that to support. Okay, so first let's go ahead and describe the other phases of the life cycle. First we seed the repository, then we experiment cycle, okay, the experiment cycle is the basic, the fundamental unit of experimentation. Two organisms are chosen from the repository, a set of seed organisms, set of evaluated organisms. Two organisms are chosen from the organism repository. They are bred to generate two children, two or more child organisms. the children are evaluated if the children perform better than the parents, then either of the parents, they are put back into the organism repository with the replacing the parents they have outperformed. Okay, 1, 2, 3, 4. Parent selection. 2, 3, 4. Breeding. Child evaluation. Repository, organism repository, maintenance. The default algorithm is to choose a parent, choose one parent from the top 10% of organisms, and the other parent from the bottom 90%, based on evaluation score. Breeding. The default algorithm is to use the basic organism breeder to breed the parent, the two parents, which will one or more, which will generate 2 children. Let's see, does the basic breeder, does it already mutate when it breeds? Okay, it does not. Breeding, let's go ahead and add that. Mutation. The children are the child organisms are mutated one or more times as set by the experiment properties. The children are mutated to introduce new behavior. So, child evaluation. The child organisms are evaluated. The default algorithm is to use the basic mutation command, seed. Where did I describe the evaluator? Organism repository, organism controller. Come on, where did I put evaluator? Seed, experiment cycle, breeding, parent selection, seeder, basic seeder, basic evaluator. Evaluator to score the children. Score the children. When the children organisms are scored, they are compared to their parents. If either the first to the other members of their family and either discarded or added to the organism repository. The child with the lower score is compared to both parents. if it has a higher score than either parent, then the low score parent is removed from the repository and the low score child is added. The high score child is then compared to the remaining family members, either both parents or the high scoring parent and the low high score parent, the low score child. If it has a higher score than either, the low score lower scoring family member is removed from the repository and the high score child is added. Okay, so there's lots of different ways I could do this. I'm just basically choosing this algorithm out of the air. I don't have strong reasons for why to do this. There's lots of different possible algorithms I can imagine. So this is just the default algorithm for how we're going to maintain the repository. Obviously, one possibility is that only the high scoring child will be added to the repository. Another possibility is that the children will replace the parents. Whatever is the case, this is only going to remove the parents, so it's not going to bump lower scoring organisms off the bottom, so to speak. The reason I'm doing it that way is so that we don't have an individual family dominate the entire organism pool. Okay, child evaluation, mutation, all right. CEDAR, basic CEDAR. Basic. Okay. Organism, okay, so the way I defined CEDAR before was it just seeds with a small set of organisms. In the past, with previous iterations of this, I created a bunch of random organisms. So I've done this differently, so I'm going to update my organism repository maintenance when they are compared. If the organism repository has not reached its maximum capacity, then the children are simply added. Otherwise, one or more of the children might replace one or both, place one or both of their parents, as described below. All right, so that's the process. Now I have the experiment defined. You saw the class earlier. Let's see. Outline. Experiment. See, the experiment here just is something that holds the cedar and the repo. What did I call it? Did I have the experiment cycle? So I really haven't done hardly anything for the experiment right now. And the seed here is just defined as cedar.seed. Okay, got it. Good. So the organisms, so we're in the classes to support the experiment life cycle here. So cedar is the interface. The basic cedar uses these organisms. Okay. Basic evaluator. Does the basic evaluator, yes, that is an interface. Let's see. Interface, okay, so for the experimentation, okay. So let's see, basic evaluator, a basic composite organism. Implementation. Okay, organisms, basic evaluator. At the end here, let's see, mutation command. Somewhere along the way, when I was doing classes, basic cedar, classes to support, okay, so basic evaluator needs another level. Okay, mutation command, mutational. Okay. So now we can say experiment. Where did experiment come from? Okay. Experiment impl. The default implementation of the experiment interface. Okay, so interface and experiment class implements mostly by, okay, auto wire dependencies. This can go down into experiment impl. The methods. Method implementations. Okay. Seed. Okay, now let's just go ahead and add the others. Void. And cycle. Okay, for now this will do. And cycle. Calls other methods. The phases of a mutation cycle are each defined by their own method. Organism list, organism select parents, list organism breed parents, list void mutate children, organism children, so let's see, do I have a how am I evaluating? Evaluator. Okay, so we'll have to say list double we're going to need a scored organism. Scored organism. Scored organism, select parents, list of organism. List scored organism. Evaluate children. list organism children void maintain repository list organism scored So those are the methods. Let's go ahead and describe these. No, that's not for now. Server details. Okay. We are going to describe these here. Select parents. Chooses one parent from the top 10% of top 10% of the scored organism repository and one parent from the bottom 90%. Breed parents. List organism parents. Simply uses the let's see, injected organism breeder to generate a list of child organisms. Mutate children. Mutates each of the children a random number of times. Random number between 1 and 5. times evaluate children uses the injected evaluator to evaluate the child organisms as described above. Maintain repository will update the scored organism repository repository as described above. Okay. Let's see, we've got where is my Markdown renderer? Okay, so there's some things I haven't done, haven't described here, like that scored organism repository. Scored organism. A scored organism is a record of an organism and its score. Methods and properties. It's just properties. For this one, let's see, how did I describe organism? Okay, we've got string ID, a basic ID to identify a synthetic key used to identify a scored organism record. A string representation of a UID is is a score a float or a double? Double. The score that resulted from evaluating the organism the string organism ID, the ID for the scored organism. Used to look up the organism from the organism repository. The organism is not stored in the scored organism repository. Scored organism repository. How did I describe an organism repository? Okay, interface. Methods. Scored organism kit by ID, string ID. Turns a scored organism record as identified. Okay. Scored organism save. Scored organism. The scored organism. The scored organism that is passed into the save method does not have an ID. The has all of the same values except the ID has been populated. Okay. Void delete or delete by ID. Just delete. Deletes a scored organism as identified by the ID. Scored organism get random from top percentage returns top percent. Returns a random scored organism from the top percentage of the scores as determined by, I don't think percent has any. Scored organism get random from bottom percent float percent. Returns a random scored organism from the bottom percentage of the scores as determined by percent. Okay. In memory, scored organism repository. An in-memory implementation of the scored organism score. Using a I am a Java developer. What is the standard way to maintain a sorted list using Java 21? Don't be afraid to ask about basics. For queue-based access. Okay. Set of string. How can I use a tree set to maintain the order based on a property of an object? I am going to have scored organisms, which will have a score, and how can I maintain a sorted list? And an organism. I need to keep a list sorted based on the score. It's going to tell me to use that comparator. But I don't want to have to sort the whole list every time I add a new scored organism. Nice. Okay. Wow. This is interesting. Sonnet 4.5. I haven't done any of this with Sonnet 4.5. This is my first time using Sonnet 4.5 for this project, and it gave me an interesting response here. tree set. The tree set scored organism allow me to efficiently find the ith element where I is any number from 1 to the size of the set. I don't think sets do that. Okay, so this is a good example of where my experience both with domain and with the code is leading me to kind of reject the first suggestion that I was given and to come up with another one. Right, a custom class. Oh, so it created ranked population. What does ranked population do? Okay. Ranked population list. Okay, add. Okay. All right, so each time it adds, it uses this binary search to find where it goes. All right, that's good to know. So list but it has to implement comparable. Okay, so that says compare to. All right, so we got to add that to scored organism. Implements the comparable scored organism interface to support binary searches in the repository. The scored organism repository. 2 scored organisms are compared using the score property. Okay, compare it to other. This method implements comparable scored organism dot compare to by comparing this organism's score with the score with other dot get score. Score by using method implementations. Okay, so I know I'm going to have to tell it how to do all the things, so I'm just going to start by telling it how to do implementations of all the methods. I'm not going to trust it to come up with its own. But this is probably a good place for me to pause the video. So that's what I'm going to do, and I will work on describing the in-memory scored organism repository with my next video. Thank you for your time.